we can use HCSR04, that is ultrasonic sensor is used with Arduino language, that too in order to determine the distance of an object in front of it. So before going to start with the program, I would like to tell something about this HCSR04 sensor. So you can see the picture over here. Uh, this sensor is having one transmitter and one receiver, and for this ultrasonic sensor there will be four important terminals. The first one is VCC, which is given to 5 volt. The second one is trigger pin. Trigger pin is an input pin. uh, this is used in order to start distance measurement of 10 microsecond pulse from an Arduino. And echo pin, it is a pulse output pin. Pulse width determines a distance of an object in front of the HCSR04 sensor. And last terminal is ground. It is connected to ground pin of Arduino board. So how the distance is measured actually? As I said, this sensor is having receiver as well as transmitter. First, what it does means it will transmit the signals like this, right, blue color like this, and when it uh, goes and stacks to the object, uh, it will the receiver from object, the receiver signal will be reflected through the receiver, and uh, the point from transmitter to an object, that is original signal, and this is the reflected signal. The point from the sensor as well as the object is nothing but the total distance, right? So how we are going to calculate the distance actually? So first, as we know, the sound speed is equal to 340 meter per second, that is equal to 0.034 centimeter per microseconds. This will be using in our program. uh, that is distance is equal to speed into time divided by 2. Why we are going to take this divided by 2? In sense, first the transmitter will transmit the signal to an object, that is 1, and from the object the signal will be reflected back to the receiver, that is 1. So 1 plus 1, that is 2. So we are going to take distance is equal to speed into time divided by 2. We should know this formula, that is sound speed is equal to 340 meter per second is equal to 0.034 centimeter per microsecond. So before going to write with the program, we should know the timing diagram of this ultrasonic sensor. First and foremost, what happens is this trigger pin will generate 10 microsecond pulse. 10 microsecond pulse. Soon after the completion of 10 microsecond pulse, internally uh, the transmitter circuit will generate 40 kilohertz sound wave, right? 8 pulses will be generated. So soon after that, the echo pin will be high. Echo pin will be high until and unless it receives the signal. That is, the width of this particular pulse is nothing but the distance of an object from the sensor to that particular object, right? From this point to this point, it is the distance which is calculated in terms of centimeter, right? So this is very much important while writing the program, right? So you can see this picture how we are going to connect our ultrasonic sensor to the Arduino Uno. So first one is VCC, as I said, that is connected to 5 volt. Second one is trigger input pin. You can take any digital input pin, right? In this picture, as per the picture, the trigger pin is given to 8 and echo pin is given to 7 as per this particular picture I'm talking, and ground pin is given to ground, right? So now I will show how we can write the program now. So first, the two initialization is nothing but the trigger pin that I have taken, that is connected to pin number 8 of Arduino, and echo is connected to pin number 9 of Arduino. And in order to calculate the duration as well as distance, I will initialize that with the long data type, and I will initialize these two variables with 0. And in the setup part, what I'm going to write is trigger pin will be acting as an output, echo pin will be acting as an input, right? So serial dot begin is by default the baud rate will be 9600, the communication between the ultrasonic sensor and the Arduino. So first serial dot begin 9600, then pin mode trigger output, pin mode echo input. So this will be initialized in setup part. In loop part, first what I am doing is I will make trigger pin high for 10 microseconds. So first we need to write this digital write trigger trig comma high, and that too for 10 microseconds. As there is a function called delay microseconds of 10 in Arduino. So directly you can write delay microsecond of 10. So soon after that 10 microseconds, automatically we need to make the trigger pin low. So for that I'm going to write digital write trig comma low. Then after this we need to make a echo pin high, so that the pulse should be on until the object is to be determined and the distance will be calculated. So for that we need to take the formula like dur is equal to pulse in. Pulse in is the function which calculates the width of that particular pulse, right, particular signal. So pulse in echo high. So how the distance is calculated? The distance is calculated, so by the above statement, from this statement I will get the something above value, that is dur. So that will be multiplied, as I said, dur into 0.0343 divided by 2. This formula is used in order to calculate the distance, right? In order to calculate the distance. So after the calculation of distance, it should be printed. So before that I will print serial dot println double quote distance. So distance quote I will give some space in order to generate the value of the distance in terms of centimeter, because we have calculated 0.0343 divided by 2 centimeter per microseconds, like that. So serial dot println, after that serial dot println, in the bracket I am going to give direct values, so that distance is equal to value centimeter it will take. So there should be a delay of 800 milliseconds after each value that I will get, right? Whenever I move the object, there will be a change in the centimeter of that object with respect to the ultrasonic sensor in front of ultrasonic sensor. So this is the theory behind as well as the program. So here is the connection of ultrasonic sensor with Arduino kit. So what I done here is I have connected a trigger pin of ultrasonic sensor to the 8th pin of Arduino Uno, as well as echo pin of ultrasonic sensor is connected to the 9th pin of Uno, and ground and VCC. VCC is connected to plus 5 volt and ground is connected to ground of Arduino Uno. So here I have placed on scale so that we can measure a correct distance, right? So first let me run the program. So done compiling, it is showing. So after that we need to upload the code. So click on upload the code. It is uploading the code. So after that it is showing done uploading. So after that we need to open our terminal here. Just go here, serial monitor, you just click on serial monitor so that it will show the centimeter of the object which is placed, right? So you can see here, right, it is showing something here now, right now. So when I keep a object in front of ultrasonic sensor, for example, if I keep a book like this, so it will gradually change. For example, here so Now the object is at 10 centimeter, approximately 10, right? You just go on moving the scale here for sorry, object, so that now the object is approximately 10.9, that is 11. So you just go on moving the object. When you move the object, it will show a corresponding, now the object is at 9 centimeter, right? 9 point, right? So 10 centimeter, right? It is showing here 10. You can see the output. Then when I move the object at 14 centimeter, for example here I will keep at a 14, at 13, you can say 13 to 14 it will show. So at end I am keeping, that is 15 centimeter. So it is showing there is a gap of 800 milliseconds in between. I am moving 14 to 15, 15 to 14, like that. So it is showing somewhat 14 here, right? So hope the concept of ultrasonic sensor is clear. Thanks for watching. Thank you.